Hi guys, we're back again with another video. So for today's video, we'll be tackling about the measure of resistance and the Wheatstone bridge. So first, what is a resistance? So resistance is a measure of the opposition to current flow in an electrical circuit. Resistance is measured in ohms, symbolized by the Greek letter omega. So ohms are named after George Simon Ohm, a German physicist who studied the relationship between the voltage, the current, and the resistance. He is also credited for formulating Ohm's law, which is expressed in this equation. All materials resist current flow to some degree. They fall into one of two broad categories: conductors and insulators. Resistance measurements are normally taken to indicate the condition of a component or a circuit. The higher the resistance, the lower the current flow. If abnormally high, one possible cause could be damaged conductors due to burning or corrosion. All conductors give off some degree of heat, so overheating is an issue often associated with resistance. The lower the resistance, the higher the current flow. Possible cause is the insulators damaged by the moisture or overheating. We say resistance may sound negative, but in electricity, it can be used beneficially. So next, we'll talk about the Wheatstone bridge, which is connected about the resistance. So Andre, what is all about the Wheatstone bridge?
Wheatstone bridge, also known as a resistance bridge, used to calculate that unknown resistance by balancing two legs of the bridge series, which one leg includes the component of unknown resistance. It was invented by Samuel Hunter Christie in the year 1833, which was later popularized by Sir Charles Wheatstone in 1843. This circuit is composed of two known resistors, one unknown resistor and one variable resistor, connected into a form of a bridge. This bridge is very reliable as it gives accurate measurements, and the DC bridge is the most common and simplest bridge network to find the resistance.
Okay, that is a Wheatstone bridge. So now, let's know more how this Wheatstone bridge works. The Wheatstone bridge works on the principle of null deflection, which the ratio of their resistances are equal and no current flows through this circuit. Under normal conditions, the bridge is in the unbalanced condition where current flows through the galvanometer. Let's watch this video for more understanding about this Wheatstone bridge and know the formula indicated in this method.
The general arrangement of Wheatstone bridge is shown here in this figure. It consists of four arms AB, BC, CD and DA, consisting of known and fixed resistance P and Q, variable resistance S and unknown resistance R respectively. These arms AB and BC are known as ratio arms. A sensitive galvanometer G is connected across the terminals B and D. The battery is connected across other two terminals A and C. Now you adjust the variable resistance S until the deflection in galvanometer becomes null. While there is no current through the galvanometer, the bridge is said to be balanced. That means voltage difference between points B and D becomes zero. At that condition, the current flowing through resistance P and also through resistance Q is I1, and current flowing through unknown resistance R and also through resistance S is I2. As we said earlier, the points B and D are in the same potential. That is, voltage drop from point A to point B is equal to voltage drop from point A to point D. That is, I1 into P is equal to I2 into R, and say this is equation 1. For same reason, voltage drop from point B to point C is equal to voltage drop from point D to point C. That is, I1 into Q is equal to I2 into S, and say this is equation 2. Now by dividing equation 1 and 2, we get P by Q is equal to R by S, or R equals P by Q into S, and say this is equation 3. Hence, we can see in the equation 3, resistance R can be determined in terms of other known resistances of the bridge.
That was a very detailed video. So now, here are some of the applications of Wheatstone bridge. Number 1. Wheatstone bridge is used for measuring very low resistance values precisely. Number 2. Wheatstone bridge along with operational amplifier is used to measure physical parameters like temperature, strain, light, etc. Number 3. We can also measure quantities capacitance, inductance, and impedance using the variations on the Wheatstone bridge. The main advantage of Wheatstone bridge is that it can be easily interfaced into various combinations. The Wheatstone bridge is traditionally called ohmmeter as the results are measured in the form of resistance and also accurate and precise. We can also measure minute changes in the bridge even in ohmmeter. The disadvantage of Wheatstone's bridge is that it is not so precise when it measures large resistances. When the large resistances are to be measured, the results are mostly nonlinear. Sometimes, the value of the resistance degrading depending on the temperature and electromotive force applied.
So as I conclude guys, a Wheatstone bridge is more accurate than the other methods of measuring resistance because the resistance is obtained using the null method and it is based on the Kirchhoff's law. In the null method, the resistance of the galvanometer and the internal resistance of the cell does not affect the null point. So okay guys, that's all for this video. I hope you understand it. Thank you for listening and goodbye.